Good day, grade 9s. In today's video, we're going to look at how to name compounds. So in the previous video, we looked at how to write the formula, and now we're going to look at, if you have to go in the other direction, how do you accurately name the compounds. But first, let's look at the questions you had to answer from the previous video. So in this first question, I kept it fairly simple and gave you simply the two elements that bind together, and you just had to go look it up on the periodic table and then follow the method. So we have lithium and chlorine, and if we look up the valency for lithium, we see that it's +1, but we don't write the 1, remember, and chlorine is -1. And then if we take those ones over, we do the crisscross method, then we see that it's Li1 Cl1, and since we don't write the ones, it is just LiCl. Then for the next one, sodium that bind to oxygen. So again, we go look up on the periodic table, the valency, we see that sodium is Na+, and oxygen is O-2. Then we take the 2 over, and we take the 1 over, and we're left with Na2O. And then for the next one, magnesium and carbon. Magnesium has a valency of +2, and carbon -4. So then if we take that over, we see it's Mg4C2. But then you would notice that both of these have a common denominator, which is 2. So we can divide 2, or we can divide 4 by 2, and we can divide 2 by 2. So then it becomes Mg2C1, and we don't write the 1, so it's just Mg2C. Okay, and then for the second question, I gave you the full compound name, and you then had to go look up the individual elements on the periodic table and find the valency for them, and then go through the process. You would notice that the second part of the name is a bit different than the element name, and you might have picked up that all of them end with IDE, and that's something that's going to be important for today's lesson as well, as we are going to try and name compounds. So some of the things you pick up here is important that you remember it for later on. Okay, but so simply, if it's fluoride, then we are talking about fluorine. Chloride is chlorine. So fairly simple. So let's look at the first one. Magnesium sulfide is magnesium and sulfur, and their valency is both 2. So magnesium is +2, sulfur -2. So those two are going to cancel out, and then it's just Mgs. Then magnesium fluoride. So now we're working with a fluoride which only has -1. So then if you take it over, then it becomes MgF2. So the 2 goes over to the fluoride, and that's why it's a 2 here. Then hydrogen chloride, both of them have, or hydrogen is +1, chlorine is -1, so it's just HCl. Then sodium oxide, sodium and oxygen. Sodium is +1, oxygen is -2, so then it becomes Na2O. And then magnesium phosphide, magnesium is +2, phosphide -3, then it becomes Mg3P2. Aluminum oxide or aluminium oxide, aluminium is +3, oxygen -2, so then it becomes Al2O3. And potassium nitride, potassium and nitrogen, so then it becomes K3N. So I hope this was fairly straightforward, as this is kind of the easiest questions that you can get regarding the writing of the compounds. Again, if you struggle with this, go watch the previous video, and if you still struggle, you're welcome to send me a message on Google Classroom. Okay, then for question 3, we are working now with polyatomic ions. So there's a list of polyatomic ions. You have to use them, and you have to get familiar with them, because you have to remember all of those, or all of these names, also all of the chemical formulas and the valencies. So, but for this activity, I assume that you probably had to go look up every time. That's fine, but just remember, for tests and exams, you have to memorize them. So let's look at the first one, lithium phosphate. So lithium, we go look up on the periodic table, and we see that it has a valency of +1. And phosphate, we go look up on that table, and we see that it's PO4 -3. Okay, and then once we get to this stage, then it's fairly simple. Just remember that everything inside of the brackets stays exactly the same. So if we take that over, then it becomes Li3PO4. And if, remember, the brackets fall away if there's a 1 outside of the bracket. Okay, let's look at the next one, aluminium nitrate. So Al +3, NO3, and a minus outside of the bracket. So then it becomes Al, NO3 inside of the brackets, and a 3 outside of the brackets. So now we keep that bracket, otherwise it gets confusing. Okay, then magnesium sulfite, Mg +2, sulfite is SO3 -2, and then it becomes, the 2's basically cancel out, so then it becomes MgSO3. Okay, so there was actually a middle step here that would have been Mg2SO3 in brackets, and then a 2 outside of the brackets, but then the 2's cancel out, and it's just MgSO3. Then sodium bicarbonate is Na plus HCO3 minus, and then those are going to cancel out, so it's just NaHCO3. Then calcium carbonate, calcium is +2, carbonate is -2, so again those are going to cancel out, and it's CaCO3. And then ammonium permanganate, ammonium is NH4 plus, and permanganate is MnO4 minus, and again those cancel out, so it's just NH4MnO4. Okay, so I really hope that you are still following up to this point, and sorry that I'm going through this very quickly. So again, if you're struggling, ask. Okay, and for the last question, we were working with transition metals with varying valency. Okay, so for this first one, copper oxide. So if no Roman numerals are given, then we use the ones that, the simplest ones, the ones that makes the most sense. So in this case, since we had oxygen, and oxygen is -2, then the easiest formation would be with copper, that is +2. So in this case, we use copper +2 and oxygen -2, so then it just forms CuO. But usually the variant will be given to you like in the other examples. So for phosphorus oxide, we know that phosphorus is +3, oxygen -2, so this one is straightforward. And then copper 2 sulfate, so here's where they give you the variant, so you don't even have to go look it up. So you know that it's copper +2, sulfate -2, so it's just going to be CuSO4. Then lead 4 oxide, so also something here, you must know your Roman numerals. So that's 4, so it's going to be lead +4 and oxygen -2, and that is then Pb2O4, which then simplify to PbO2. Then iron 4 oxide is going to be similar, which results in FeO2, and iron 3 carbonate is going to be Fe +3 carbonate -2, which then results in Fe2, and then in brackets CO3, and outside of the brackets 3. Okay, so make sure you get that right. Make sure you have all of the questions right. If you don't, redo it and make sure you understand it. Okay, and then finally for today, we are only going to be focusing on one thing, how to write the names of compounds. Okay, so that's the only thing you should be able to stick and say, yes, I can do at the end of this lesson. Okay, so when you are naming a compound, you are always dealing with two parts of the name, two parts of the compound, the first part and the second part. And we call those two parts the cation and the anion. Now, you don't need to know those names. Those are just simple or fancy names for positive ion and negative ion. Okay, so you always have the part that is the positive one and the part that is the negative one, and that's the valency. So positive valency and negative valency. And we name the cation or the positive ion first. So that's the first part of the name is always going to be the one with the positive valency. And we don't make any changes to that. We just use the elemental name, write it or just as is. And it doesn't receive any special suffix or anything. You use it just as it is. The changes are going to come to the second part of the name. So if we look at the anion, the second part of the name, then this is where you make a small change to the name of the element and you just add a suffix IDE. So it just becomes, for example, oxygen just becomes oxide. So you just add that IDE, that suffix, to the end of the name. You just replace the last part of the name with IDE, and then you add the two parts together. So then in this case it would be lithium oxide. Okay, so I hope I'm making sense. It's quite late when I'm making this video, but it's up to this point still quite straightforward. Then if the name contains, or if the compound contains polyatomic ions, then we just call it that polyatomic ion. So again, we don't make any changes to it. So if we are working with phosphate, then it just becomes lithium phosphate. So now we don't add the IDE. We just call it the name of the polyatomic ion. And if we are working with an element with a variable valency, like iron or copper, then we must indicate that variant that we are using in brackets, because the person who reads the compound needs to know what combination iron and chloride or iron and chlorine bound together. So we need to use the variant in brackets, and that variant is written in Roman numerals. Okay, so in this case, iron chloride, since it is iron plus 2 that was used in this compound, it is iron 2 chloride. Okay, and if you are unsure which variant is used, then you must use your knowledge that we gained in the previous video to figure out which variant was used. So for that, you need to use the other element in the compound. So in this case, you would use the chlorine to figure out what specific variant of iron was used. Okay, but like in the previous videos, let's look at a few examples, because that's going to help us demonstrate all of this. Okay, so let's look at these three examples. The first one, we have Na and Cl, so that's sodium and chlorine. So if we add those two names together, then the INE changes to an IDE, and it becomes sodium chloride. Then the next one, we have iron and sulfur. So iron can either be a +2 or a +3. So now we need to figure out which one to use. Well, like I said, we can use the other element and figure that out. So now we have to do a bit of reverse engineering. So let's write the compound formula, and then we use this equation from the previous video and we work backwards. So now we try and figure out what the valency was so that we can correctly identify the variant of ion that was used. So if we take the 3 and the 2 over, then we see that the variant of ion used in this example is 3. So because the 3 from the sulfur goes over to the ion. So it's Fe3 plus sulfur minus 2. So we name this iron 3 sulfide. Then the next one, we have Ca and then CO3. So this is a polyatomic ion, carbonate. So you need to remember this and identify that correctly. So in this case, we don't need to make any changes to this because it just stays as is. So it just becomes calcium carbonate. Okay, I hope you understand it at this point. And as always, I'm gonna give you an activity to do to practice what you've learned. Okay, so there's only this one question, one activity for this section, since it's all fairly straightforward, but mixed in here is a bunch of different examples with some polyatomic ions, some transition metals with varying valency. So if you can name all of these, then you should be fairly set for naming compounds. So just do these couple of examples and we'll mark that in the next video. Okay, good luck.